So in the last class, we covered the area of square and the area of rectangle. Okay, this class we will start with area of a parallelogram. Okay, we will do the area of a parallelogram and we will see two methods for it. Okay, two methods for it, the graph method and the normal method. Okay, so let's take a look at the graph method first. Just give me a minute to open it. Graph method. This is the area of a parallelogram by the graph method. Now, in this method, what happens? A parallelogram is drawn on a graph paper. If you can take a look at this figure, okay? Can you all see a parallelogram? A parallelogram is here. It's if I join this line and this line, can you now see the parallelogram? Okay.
Yes.
So yeah. So this is the parallelogram that we have in this question. Now the question says that AP is perpendicular on BC, okay, and CQ is perpendicular on AB. AP perpendicular on DC means that, can you see the line AP? Can you see this line AP, okay, is perpendicular on this line DC, okay, and then it says that CQ is perpendicular on AB. This is the line CQ. This is CQ. It is perpendicular on AB. This one. Okay. Now, if we just draw the two straight lines on the two sides of the parallelogram, we will get what? We will get two triangles. Okay. We will get two triangles, and in the middle part, we will get a rectangle. Okay, in the middle part, we will get a rectangle. So this is what they have done, that they have drawn two lines here. Okay, they have drawn two lines here and they have made this parallelogram into two triangles and one rectangle. Okay, okay, it's okay, Dara. You can listen to it right now in class, and at home you can do it. Okay, later you can do. Yeah. So now two triangles at the side and one rectangle at the center. Okay. Now in the graph paper, I explained you all that this one box is of how much? 1 centimeter.
Centimeter square.
Yes, 1 centimeter square. Okay. So the area, suppose let's take a look at this triangle ADT. Okay. So this DP is how much? 2. Okay. DP is 2 and AP is how much? 4. AP is 4. Okay. Similarly, in the other triangle also, if you take a look carefully, this QB is 2 because it's covering two boxes and QC is 4. Okay. Now I
Ma'am,
have the height.
ma'am,
Yeah.
congruent.
Yes. So they are congruent, yes. But now I have the measures of the height and the base of both the triangles. Okay. 4 is my height, 2 is my base. Now, can I find the area of the both the triangles? Can I find the area? I can use the formula area of triangle APD equals to half into base, that is 2 into 4, that is height. Cancel 2 and 2, we get 4 centimeters square. Okay, we have the area 4 centimeters square for the triangles. Okay, and area of triangle similarly CQB, the second triangle also becomes CQB, also becomes 4 centimeter. Okay, because again the base is 2 and the height is 4. Now we will see the now we will see what? We will see the rectangle. Okay. Now, two triangles we calculated. Now, let's take a look at this rectangle in between them. Let's use a different color for it. This is the rectangle that is there in between them. Okay. This rectangle is now rectangle. We have the length. Okay. Sorry, we have the breadth 4. Okay. Now calculate the length. Calculate the length. Count the boxes. 1, 2, 3, 4, 5, 6. Okay, so this is 6. This thing is 6 from here to here. And this thing is also 6. Okay, so length is 6, breadth is 4. Area of rectangle, length into breadth. Okay, so of area of rectangle ABCP. Oh sorry, not P. This will be AQCP. AQCP. Can you see? A, then Q, then C, and then P. Okay. AQCP equals to 4 into 6. That is 24 centimeters square. Okay. 24 centimeters square. Now, the area of both the triangles, we have 4 centimeters square and 4 centimeters square. And the center part, the rectangle, my area is how much? 24 centimeters square. So to find the area of parallelogram, we will add the area of parallelogram equals to area of triangle plus rectangle. Okay, area of triangles plus area of rectangle. Area of triangle is how much? 4 plus 4 plus 24. Okay, now we will get 32 centimeter square. Okay, this way we will find out the area of the parallelogram on a graph. Okay, now how to know that what is the measure of the sides? Okay, what is the measure of the sides? Like I said, you can count the boxes. Okay, for each centimeter, 6 boxes that makes it 6 centimeter the side. Okay, 4 boxes makes the side 4 centimeter. Like
Ma'am,
that.
8 boxes.
Yes, Edric.
Ma'am, 8 boxes. Ma'am, the base is 8 boxes and the vertical height is 4 boxes. So 8
Yes.
into 4 is 32.
Yes, Edric. Okay, so that is right. Also, we can do the area of parallelogram. Okay, now I am just erasing all this from the diagram. Now, if I check the complete parallelogram, okay, the whole parallelogram thing all together, then DC is my base. Okay, DC is my base, and AP is my height.
Your
AP,
vertical
yes, the vertical height. Okay, so AP, how many boxes? 4, so 4 centimeter. DC is how much? How many boxes?
8.
6 into 8. Okay, so 8. So directly you can find area of parallelogram, area of parallelogram is equals to base into height. Okay, base that is DC into height that is AP. Okay, so base is 8 into 4, 32 centimeters square. Okay,
So basically, that is if you take one of the triangles and add it to the other triangle. So instead of a parallelogram, that is like a rectangle, right?
yes, yes, Simran, that is right, like a rectangle. Now, take a look at this diagram. Okay, let's do that thing. Okay, remove this triangle. Okay, remove this portion. Okay,
Now
remove
it's a
this.
trapezium. Now it's a
But
trapezium.
what we will include? What we will include? We will include this portion. We will include. Can you see a rectangle now? Okay,
Um,
so
that's
now
rectangle.
this is 8 again. Okay, 8. And this is
Hmm.
how much? 4. So now, if you remove, like, take that part and put it here, okay, make it a rectangle and do length into breadth, okay, this is rectangle RQCD, okay, area of rectangle RQDC equals to length into breadth, 8 into 4, 32 centimeters square again. Okay. So in parallelogram, there is this thing that if you cut out one portion, one triangular portion, place it here, it becomes a rectangle, then you can use the rectangle formula and find out the area. It will be the same as the parallelogram area. Okay, why? Because again, the portion of the parallelogram is not changing. Okay, we are just changing the shape, but the original portion of it, okay, the area portion, that remains the same. All right, now you got it? Yes, yes, Abraham.
Ma'am, the account of the point won't count, ma'am, is because that doesn't have any centimeters, right, ma'am? Because that's just an inch.
The point doesn't count. You mean to say this thing?
Yes, ma'am.
No, we count it by boxes, okay? We count it by boxes. In the line graphs and all, those things we count, like we check out the points when you make the points and then you join the lines,
Ma'am,
okay?
ma'am, so there's two ways to find the area. Which way is better?
Which way is better? The original way to find the area of parallelogram base into height is better, okay? Because it's a shorter method. All right. Then again, there is a bigger method. You find the area of the triangles, find the area of the rectangles, sum them, okay, add them up, and then find the area of the whole thing. The first thing that I showed you, the first method, the above one. Okay. Then the third one is there. Okay. Like you this include the area of this side, and then you add that thing here, okay, and then find the area of the rectangle only, base like length into breadth. That thing is also there, but again, this one might be wrong. Okay, this one might be wrong. Like because like if you take the wrong measure, that this triangle that you have disincluded and you add it here should be exactly the same to give you the right area. Okay, should be exactly the same. If you just make it only like this much bigger, suppose I don't have a graph paper, then it will be wrong. Okay, then it will be wrong. So, what is the best formula? Directly doing base into height. This
That's
is
not a likely case. It's because parallelograms can be drawn anywhere. I understand that, ma'am. But, ma'am, you can always cut the triangle almost in the right way, and also if the sum of the parallelograms have to equal to 360 degrees because the sum of quadrilaterals are 360. And so both the angles should be the same.
Angles should be the same, yes. Even
Otherwise,
the
it
sum of
won't be considered as a parallelogram. It's considered as
even the sum of the
a
yeah. Mm-hmm. Even the sum of the rectangle, all angles of a rectangle is also 360 degree.
when somebody normally asks you to find the area of a parallelogram, he normally asks you to not find the area of an uneven parallelogram like with different triangle sides. The question will normally ask you to find a normal one.
Mm-hmm. Normal one. Yes, if the base and the height is given to you directly, you can find out very easily with the normal formula. Okay, and if like in the graph paper, I can put the exact, like I can cut the half and place it on this side in the exact thing, like I can do. But if it is on a normal paper, if I'm doing it on a normal plain paper, then it might be that this triangle I might make it bigger. Okay, someone might make it bigger. Okay, so and the first one is lengthy. All right. So second one can be used. Mostly the second one is used. Okay. Baki, the other two are for your explanation, are for to make you all understand that how it relates with the rectangle. What are the other ways in which we can find it out? Okay.
Ma'am,
So, ma'am,
Yes.
you
Hmm.
can normally if you question once you do the method, it will put an arrow showing the height. It will say this much centimeter.
Mm-hmm.
You put an
ma'am,
arrow.
Yes, you can put an arrow showing the height. Okay. 4 centimeter. Okay.
ma'am,
Yes, Edric.
ma'am, you can also find the area of the triangle like this, ma'am. See, ma'am, there are two complete squares in the triangle. Then one square is more than half, then the next square is less than half, then next square is more than half, next square is less than half. That means two squares are less than half, I mean they count as zero. There are two squares more than half, they count as one and two complete squares. So 1 plus 1 plus 1 plus 1. The area of the triangle is 4.
Okay. Okay. This is yes, Edric. I got your point. I can see that now. Okay. So what Edric is trying to say is these squares, two squares are complete. Okay. So 2 into 1, 2. Okay. Plus. Then two squares we have which are more than 1 or more than half. Okay. That is this one, okay, more than half, and this one more than half. So again, 2 plus 2 into 1, okay, that is 2 plus 2, all right, equals to 4 centimeter square. But the rest of the two, why we have not taken this one and
Because it
this
is
one?
less than
Because
half.
yes, because it is less than half. So that is right. This way also you can find the
But
area
it
of a
can't be
triangle.
always accurate, right? This method.
It can't be, this method can't be always accurate. Mostly it is, but only on a graph paper. Okay.
You can be
Yeah.
accurate, ma'am. If you want to find
Yes.
the area of a triangle, what you can do is you can draw the same triangle on the other side, then find the area of the rectangle and then divide it by 2.
Area, same triangle on the other side. Okay. You were saying to make it like this. Here and this whole thing. You're saying to do this whole thing. So it becomes 8. Okay. So it becomes 8 squares. 8 squares. Okay. So divided by 2 gives you 4. That is area of half part of the triangle. Area of your triangle. Okay, Abraham. This is also good logic. Okay, Simeon's part, Simeon, we can find it. Okay, and yes, it is accurate, but you have to like, but this only works on a graph paper. Okay, this counting the squares wala method only works on the graph paper, and also, what I was trying to say, yes. You have to get it right, okay? All the squares, you have to get it right, all right, to get it accurate. Okay. So now we did the area of a parallelogram by graph paper. Okay. Now doing the normal area of the parallelogram. Okay, how this formula space into height is obtained. How this space into height thing is obtained. Okay. Um,
I have a question.
yes, Abraham.
Ma'am, when you did this test, did you only ask based on the height or did you ask all the formula for the parallel?
Can you repeat the question?
When you give us to solve this test, will you only ask base into height or everything, like all the formulas?
All the formulas. I might only ask you to find the area of parallelogram without mentioning the specific method. Okay. You can use any of the method. All right. But I'm just telling you all that mostly, in most cases, the base into height method is used. Okay.
Ma'am, there is a criteria for the base into height method.
Is there a
And
criteria for
all
the
the
base?
methods. Ma'am, there has to be an arrow showing the height
There has to be an arrow showing the height.
for
Yes,
answer.
Abraham, an arrow is put to show the height in the answer. That you can put, okay? Okay, yes, Simeon. Wanted to ask something? Okay. Okay, so I'll open the whiteboard. Just give me a minute. And
Ma'am,
yes,
for
Abraham.
solving an area of a trapezium, ma'am, we do this. We don't do. We first make it a parallelogram and then solve it, right?
First, we make a parallelogram and then solve it. Yes, Abraham, we can do that.
And ma'am, another way I think is to split it into half, find do the triangles and then do the square, then do the rectangle and then add them all up.
Do a rectangle and then a triangle. That thing can also be done. Okay,
Okay.
do a rectangle. Okay, extend and do a rectangle, then do a triangle. Okay, sum them up. Okay, to find the area of the trapezium. That thing can also be done. Now, take a look at this parallelogram.
Ma'am, we'll get a triangle.
Yeah, I made a triangle.
Another triangle.
Yes.
Good. And 4 triangles.
Yes.
6 triangles.
You
Four
can like
triangles.
divide it into 6 triangles and then further divide it into um
Ma'am, how many triangles do we have to make? 6 or 4?
And
Four.
you can put
Four.
10 triangles.
4, 5, 6.
Okay, that's it. Okay. Okay, that's all the triangles that we are going to do. Now,
Ma'am, explain me how to put 10 triangles.
how to do 10 triangles? No, I'm not explaining that right now. Okay.
One more.
After class, after class, go home, like at your home, try to make a parallelogram and then make 10 triangles in it, okay? But right now, explain, like, understand how the formula is derived, okay? So, in this figure, can you see the triangle ADC and ACB? ACB, that is this triangle and this triangle, okay? ADC and ACB, okay? So, the area of parallelogram can also be obtained by doing the sum of ADC and ACB. Okay, so area of parallelogram ABCD, area of ABCD equals to area of
ADC.
triangle ADC plus
ACB.
area, yes, of triangle ACB. ACB. What's the area of triangle? Half base into height. Okay, so we can write that equals to half. What is the base of triangle ADC? DC. Okay, half DC plus, sorry, into height is what? AP. Okay, or you can just write H. Okay, plus half. What is the base of CB? AB.
AB.
Okay, AB into its height. Okay, into its height. So, what is common in both of them? The height. Okay, the height is coming in both of them. So can we write it like this? We can write it like this: half height, okay, into BC plus AB. Half height into BC plus AB. Okay. Now, is BC and AB equal? Yes. BC and AB are equal to each other. Okay. So we can write half half height BC plus BC, okay, because DC equals to AP, okay. Then DC plus DC becomes 2DC, okay. So 1 by 2 height equals to 2 DC, 2 DC, okay. So this 2 into cancels, okay, this is into this multiplication sign, okay. So what remains? HDC, HDC, okay, equals to AP into BC. What is AP and BC? AP and, don't write this BC, write this, let's name it Q. Okay, AP into QC. Is it DC only? 1 second. Is that a misprint? Height equals to AP. Height equals to AP. Yes. Yes, Abraham.
Mom, will we ever need to write such a long explanation in the exam?
Will you have to write such a long explanation in the exam? Abraham, 1 second. This is, okay, 1 second. This is D C only. Okay, this is DC only. Since AP is the height and DC is the base. Okay, and height, because height equals to AP. Height is AP. Okay, and we will multiply the height. Okay, with the base. So that gives us the area of parallelogram. Therefore, area of parallelogram.
Now, what is 11 gram?
11 gram. 11, that is not 11, that is a sign of parallel. I've written in its short form parallelogram. Parallel and then gram. Parallelogram equals to base into its corresponding height.
So, ma'am, will we
Yes.
ever, so ma'am, when the test comes, will they ever ask us that how did the area of parallelogram come? And we have to write the explanation.
How did the area of parallelogram come? Like how, like what is, how is the formula derived? How is the formula of parallelogram derived? So, Abraham, mostly this question is not asked, okay? Like in these things, okay, other derivations, like I have taught you, those maybe can be asked, okay? But this thing comes rarely, okay? Like how the, like explain how we derive the area of parallelogram, okay? But yeah, since it was there in your text, okay, I have done it with you, so now you know. Okay, now you know. But this is like probably it is not asked. Okay, but rarely, like I said, rarely. So might be asked, like very less chances. Okay. So yes, Cedric,
Ma'am, two triangles put together always make a quadrilateral.
always make a coordinate. Yes. Yes, Cedric. Okay. Now,
Ma'am, so will you be asking it?
will I be asking it? Um, cannot really answer that right now. I'll see, Abraham, if I'll put it in the test or not. Okay. But since it is there, then you have to study. Okay. You have to study. All right. So we will stop here today. And the next thing that we are going to cover is
Ma'am, I'm not done copying.
okay, copy it, and then tomorrow we will do area of a trapezium. Okay. Trapezium, after trapezium, we'll do circle.
Ma'am, when is the test?
When is the test? I think I'll be keeping it on Tuesday next week.
Okay.
Please keep it
Okay.
on this day, ma'am. Chapter 15 test.
Can you what is it actually? Say it again.
Please keep the test on this Friday.
This Friday.
Edric,
Just
we
a little
cannot do
time.
the test on this Friday. Edric is because it become a little difficult is because I'm going somewhere on Sunday and I won't be able to pack and do the test.
That means you can submit by Saturday or Sunday. Ma'am,
But again, that is a weekend night, Rick. That is your weekend.
ma'am, you share it on Friday.
Abraham can do on like Saturday, you're saying. But Anaya is also unwell right now. So I'm thinking to just keep it next week itself.
Please on like Sunday or something.
No,
Edric, give it
not Sunday.
it's only one day to prepare.
Not Sunday. Yeah, it is like this day after tomorrow is pretty soon. Okay, so Tuesday only we will keep. Okay, Tuesday only we will keep.
Oh,
And
late. This week at least can keep
it's
one
not, not
by this.
late. It's not late. See, Edric, what happens is that this week I'll be able to finish this chapter then. Okay, in the next 2 days, I'll be able to finish the trapezium and the circles. So this week I'll be able to finish this chapter. and then the test can be taken the next week. And also, I got some suggestions from you all only to keep the revision classes for the ninth chapter once again. For the it is that chapter, simple interest and compound interest. Simeon, what do you think?
Yes.
Yeah, Abraham also and Anaya also asked. Edric, I'm planning, like, since most majority wants me to do that before our half-yearly paper. Half-yearly paper I'll be sharing on the 23rd. Before that, to give you all a revision of this thing, you'll be starting your breaks from the 23rd. So before the breaks, if you all want the revision of any chapter of maths, we can do it. Okay. Like after this week, once we are finished with this particular chapter, we can revise this ninth chapter, simple interest, compound interest. One more chapter you guys told me. I think the fifth chapter, algebraic equations, right? Abraham and Simeon.
I don't think I said that.
I remember y'all telling me. I think Abraham and Anaya said to keep to revise the fifth chapter also. Algebraic expression one.
Ma'am, do
Okay.
that.
You want that, Ajay?
Ma'am? No.
Yes. Okay. Okay. So those classes, but I'll be giving you all a revision. I think 2 days, 2 to 3 days for the ninth chapter. Okay. Revise all the concepts, revise the formula. Okay. I'll try to do like 1 or 2 examples also with you all. Okay, from simple interest, compound interest. Zara, you can also join in those classes. Okay. So
So
you know
for
concept.
simple interest and compound interest, we have to like learn. I mean, for different chapters, we have to learn all the different formulas for each question, right?
Yes, Sunil. For the chapters, you have to learn the formulas. And I don't really say learn because when you're practicing the sums, okay, when you're understanding the sums, it is like it sets in your mind the formula. Okay, without you needing to cram it up, it is set in your mind. Okay, the formulas. So that way, like when you practice the questions more, you'll be able to remember the formulas as well. Okay. Half-yearly papers are, if you want more like time, because since you were not there in the previous, all the starting chapters that I've given in the test. Okay. So if you need more time to prepare, you can prepare. Just don't look at the test paper. Okay. But take some more time. If you want, take the month of January also. Okay. And do the chapters that are there in the test. Okay. Cover them first. Okay. And then do the rest of the chapters. But I'll be starting the next session, I think, by the end of February or March. That time, Zara, you can join with me again. I will do the whole thing from the beginning. Okay. That time, I'll do every chapter with you from the beginning. Okay. Okay. So that's it for today in maths. Tomorrow we'll be meeting. Yes, Abraham.
Ma'am, is there any other test other than the written chapter and the half yearly paper happening this year?
Is there any other test besides these? No, not right now. Okay. But if I plan to keep any, I'll let you know.
Okay, ma'am.
Okay. Okay. Okay then. Okay, Zara. Enjoy. See you all tomorrow. Bye.
Bye,
Bye,
ma'am.
ma'am. Thank you.
Okay. Bye. Okay, Edric. Sorry. Abraham and Simeon. 2 minutes break. Okay. Go and bring your things. All right.
I'm
Bring,
just I'm mixing up my name.
mixing up what?
Normally called Edric Abraham. Now you're calling me Edric.
Mixing. Yeah. Because I'm like mostly answering to you, you both only, no? Either I'm answering to Edric, either I'm answering to you. So that is why. Okay, go bring your things. All right. And then we'll start with experiment. In 2 minutes, we'll start.
Ma'am, one problem, ma'am.
What is it?
I took 2 teaspoons of oil.
You took 2 teaspoons of
2
oil.
tablespoons of oil. Because teaspoons, because one will only coming to this much.
Okay. Okay, Abraham, no problem. It's okay. Okay, both of y'all are ready?
I'm
Abraham,
not ready.
Sunil?
Just 1 minute.
Not ready. Okay, okay, okay. Sure.
And I'm ready.
Okay.
I'm ready.
Ready? Okay. Videos on, please. Okay. Yes. So, first thing that we are going to talk about is the density. Okay. Can any one of you tell me what is density?
Mama, I remember when I was when I was 11 years old, I went to my I had gone to this homeschooling co-op where we were I don't remember there was a science exhibition where somebody was doing about density. It was two people were doing about density. They put different liquids in a bottle and then they tried to and they were measuring the density of that.
Mm-hmm. Okay. Yes. So basically, if I talk about the density, I'm sharing my whiteboard. Okay, I'm
It's
sharing
like
my.
how much the mass is packed into an object.
Yes, that is correct, Sunil. How much a mass is packed in an object? Okay, three objects are there. Okay, this is solid. Okay, this is liquid. This is
Density is about the atoms, right? How much of the atoms are tightly packed, how much are they widespread?
yes, or the molecules. Okay, or it is defined as the mass per unit volume. Okay, that is, it can be said that it's essentially a measure of how tightly a matter is packed together. If I say about solid, it's packed closely together. Okay, it's like closely packed together. Like this. Okay.
Solids are more dense than liquids or
Yes,
gases.
yes, that is correct. If I say about liquid, it's little bit far. Like molecules are little bit far. Okay. And if I talk about okay, gases, then they are very far. Okay, like they have a lot of distance.
The solid
Loosely,
is
very
most
loose.
tightly packed.
Yes, solid is like completely packed. Liquid is like little bit, and then the gas is like completely distant. The molecules are from each other. So density is essentially a measure of how tightly the matter is packed together. Okay. Now, do you all have water in a glass? Take a glass and pour water in it, and please show me while doing. Okay, turn on your videos, and when you are doing it, I want to see. So please show me. Okay. Okay, I can see Abraham's.
Ma'am, I got this cup to mix everything in.
Okay. All right. Firstly, you just put water inside this one, this longer one, the glass. Fill it, like put it more. No, no, take the glass out, the smaller glass out. Okay. And pour it, fill it like more than half, three-fourths. More, put more some, put some more. Yes, that's it. Okay, do you have a lemon that is not cut, Abraham? I can see a lemon has been cut into pieces. A full one?
Ma'am, should I take some water out?
Um, you need to take some water out, you're asking?
Yeah, ma'am, should I throw some water out?
Yes, throw some out. Okay, if Simians, I can see Simian moved a little to the center, little bit to the center. Okay. Mm-hmm. Okay, I can
So
see.
what are we supposed to do?
What are you all supposed to do? You all are supposed to take the lemon now. Okay, Abraham's getting his a full lemon. Okay, got a full lemon? Yeah. Oh, it's not fitting. It's pour the water in a glass and then rub the lemon. Okay, pour the water in a glass. They take about half or just a
I took
little
the
bit more.
bottle so that it can be seen. Wait,
Take a transparent glass also. It will be seen in that way. Abraham got a full lemon? Yes, yes. This will work. Drop it in.
So,
Yes. Very good. So this is sinking. Okay. This is sinking right now. Okay. Watch it sink for a minute till Simeon does it with his thing. Simeon, can you like speak while like doing so that it will be displayed like on my bigger screen? Unmute yourself. Yeah. Is it in, Simeon? Why is yours floating? It's supposed to sink.
I know, but it's floating.
I don't know why it's floating. It's
ma'am, maybe lemons in Malaysia are different.
Yeah, in Malaysia you can get Indian lemons, but there's another weird, like giant kind of lemon. And I think this is that kind of lemon.
this is that kind of lemon. Okay. All right. So the thing was, the experiment was that we will take the lemon and it will sink in the first try. Okay, the normal lemon. Okay, Indian lemon. It
Ma'am,
will sink in the first
thinking
thing.
completely. Because the glass is too small, guys.
Yeah, I think that's because the glass is small. It needs to be wider at the bottom. Okay, but it will sink in the first thing. The lemon will sink. Okay. I don't know why Simeon's Malaysia lemon is not sinking, but it's okay. So now we will, the main experiment is now take the lemon out and add salt in the water. Okay. Add around 1 tablespoon of,
Ma'am, this much?
show Abraham, this much, yes, this much, put it in. Take the lemon out first.
We should do what? Take the lemon out and
Put 1 tablespoon of salt inside the water.
Ma'am, I made a toy.
You made it turn.
No,
Okay,
a
I can see
toy.
a toy. Okay,
The lemon and a glass.
lemon and a glass. Take it out now. Use a spoon or something. Yeah. Okay. So now you have mixed the water now. Mix the salt in water. Okay. Abraham, now mix it and then put your salt in. Sorry, lemon in.
So, ma'am, you want me to put my lemon back again?
Yes, yes, yes. Take out the spoon and then put the lemon back in.
And my water's not mixing so well is because it's actually it's a little cold over here.
Yeah, that happens. Take the lemon and put it in.
Ma'am,
Or
to remove it.
yeah, what?
Will we have to remove it afterwards?
Yeah, you no, like so it will float. Okay. This is the same thing that happened, okay, with the lemon. Okay. What this salt does to the water, it increases its density. Okay. Like
this will
firstly,
work
when
with an egg.
this will work with an egg. I think so, Simeon, probably. Try with an egg, Simeon, if you can. Okay, yeah, it has sink.
It's
With
sand.
the water,
So then I have to add salt.
yes. So take the egg out and then you add salt. Okay.
Ma'am, the egg's not coming out. It's stuck.
Egg is not coming out.
And ma'am, it's a raw egg.
Okay, that's it, Simeon. Okay. Now mix it, but take care that the egg doesn't break. Okay.
And I'm spinning, the egg is coming upward.
Yeah, it's trying to come upward because it will float. Okay, because it has increased, the salt will increase your density of the water. So the egg is going to come up and float. Firstly, it will sink, and then the second time it will, after you add salt, what it does, it brings the molecules closer, like the salt particles, when it mixes with the water molecules, it makes it more denser. Okay, it increases the density of the water. All right, the density of the water is increased, so the egg will float. The egg, the lemon, those things are gonna float.
The salt is not yet completely mixed. Okay, it's
Yeah.
mixed. It's floating like halfway.
Ma'am, I made the density.
Can you show?
Ma'am,
You
see,
made it.
salt, then here's the water. Here's the salt, here's the water, and then here's the normal clean water, and then the egg.
It's floating
Okay.
like higher than before.
Higher than before. Okay. So, Simeon, maybe the egg, since the egg is much heavier, Abraham, show yours. The egg is heavier. Okay. So, what happens that you need, I think, the water needs to be made more dense. Okay. The water needs to be made like even denser for that egg to float, since egg is
Drop
heavier.
the glass. Ma'am, should I throw on a glass? Because the egg is stuck in the middle of the glass.
Yeah, yes. Now the experiment is done. This one is done. So you can
Okay, give me a
throw it.
minute.
Yeah. You all can throw the water. Okay. Take out the egg, the lemon, everything. Can you see this image on my screen? What happens to the molecules? Okay. The blue molecules are the molecules of water. If you can see, the molecules in warm water are pretty far away. Okay, are far away. Then in the center is the cold water. Okay, the molecules are cold water. They are not too far away. Okay, a little bit close, but they're still far away. Then in the third image, in the third glass, is salt water, what we made. Okay, this salt water. So the white molecules you can see are of salt. Okay, so what happens is that now the salt molecules goes in, fills in the gap of those in between those molecules of the water. Okay, in between those molecules and the water, it makes that gap, like fills that gap, and then it increases. This thing increases the density of your water. Okay, the third thing. salt water, you can see it has become denser, the water. Okay, increases the density of water. Okay, okay. Got the concept, guys? Can you all tell me a real life example of this thing that happens? Any real life example?
Ma'am, a ship floats because of density.
A ship floats because of density. Okay. Anything else? Okay, so heard about the Dead Sea? Heard about the Dead Sea? Yes, that is an example of this stick only. Why do people don't drown in it and just float on the surface? Is because the water has a very high amount of density. Okay, because the water of that particular sea has very high amount of density. So nothing drowns in it. Everything will float. Okay, Simeon, like I can see 1 second, Simeon. Yes, Simeon.
So and then you can even check the age of the egg by putting it in water. Like an
The
old egg,
age.
like a new egg will sink,
Mm-hmm.
but if it's like 2 to 3 weeks old, it will like sink, but it will be slightly floating, like very slightly.
Slightly.
And if it's
Very
old, it will be floating at the top because
floating at the top.
because when it's old, the air there's more air inside it,
Mm-hmm.
and the
Yes.
yolk begins to contract. So then it's
Yes.
less denser.
Ma'am,
Mm-hmm.
that's why my egg sunk is because it was a little old. See, not old, it was new.
Okay, it was new. Yeah, so Simeon, I think you increase the density of the water, right? To make it float.
Yeah.
Yeah, okay, good. So this is how density works. Now turning like coming back to the next one. Okay, coming back to the next one. It is about the solubility and insolubility. Okay, solubility and insolubility. So now take water once again in another glass or something. Water once again in the glass. Abraham has poured oil already.
No, ma'am.
No, water you poured.
Yes, ma'am. Ma'am, I'll not be able to take a picture of the experiment this time is because I'm using the same glass.
Okay. No problem, Abraham. I'm taking your pictures while doing it. Okay. While doing the experiment. All right. Okay. Have the water. Now, take 1 or 2 teaspoons of sugar and mix it in the water.
For some reason, the sugar is wet and it's dripping out.
It's dripping out. Do it with a spoon if it's not entirely coming out. You can do it with a spoon.
Yeah. This is really oil.
Ma'am, I want to say that sugar doesn't dissolve in water.
Okay. Dissolved in normal water. Yes. So sugar is a substance that is dissolvable. Okay. That dissolves easily in normal water.
Ma'am,
Okay. What?
it doesn't dissolve in water.
Hasn't dissolved in water. It will dissolve. Like if you will keep dissolving it, turning your spoon, okay, it will dissolve. Right? If you keep doing, it takes time. Yeah, sugar takes time to dissolve. But yeah, the particles, if you keep dissolving, dissolves. Okay. I think that is because of the spoon and the glasses, like thinner at the bottom. That is why probably. Okay,
When
then
stop stirring, the sugar becomes lesser.
lesser, yes, because it is getting dissolved. Okay, so it is becoming lesser. So the sugar, high purity sucrose, yes, that is right, Simeon. And now, second thing, okay, Abraham, it will dissolve. Okay, let's move on to the next part. Okay,
Water
let's
tastes
move.
very nice after that.
What? Yeah, it becomes sugar water, and then you have lemonade also. Make lemonade later. Okay. So, yeah, you have the lemon. You got the lemon. You got the water. You got the sugar. Salt also you got. Okay. You can have a lemonade after class. All right. So the next thing, take another water. Take water in another in a different glass. Okay. You can keep this one at the side. Take one more glass and put water in it.
I don't have another glass.
I have another glass. Then pour this water back in some other container or something.
I don't have another glass like this.
Another glass like this. It will work, Abraham.
I have a glass. Yeah,
Another glass like this can also work. Okay, a transparent glass. Okay, now pour some fresh water in your glasses. Okay, pour some fresh water in your glasses.
Oh, yeah.
then
And okay. Now, Simeon start. Pour some fresh water in your glasses. Then, now take oil. Okay, put around 1 or 2 tablespoons of oil in your water. Okay, now take a spoon and try to mix this. Okay, Simeon, I can see. Yeah, I can see. Yep.
I mixed it and it's getting smaller, like very small droplets.
Okay, it's getting very small droplets. Okay. Abraham, mix the oil in the water.
It looks like air bubbles.
ma'am, I can do decantation with this oil.
Decantation in this oil. Yeah, first try to mix it with spoon in the water. Okay, mix it for like some seconds, and then take your spoons out. Take the spoons out. Okay, and then
Ma'am, it looks like
Simeon, you are muted. Muted.
I didn't say anything.
Didn't say anything. Okay, Abraham has left I think because of network issue. So what happens with this oil is that it comes together. Okay, this oil, it comes together, like it doesn't dissolve in water. Okay, the oil is an insoluble substance. Okay, it doesn't dissolve in water. All right. So what happens is when if you try to mix it or something, it breaks into small droplets. When you leave it, it will again come together. Okay, the small droplets slowly, it will again come together. High pressure oil can dissolve in water. Okay, 1 second, let me read that. Yes, but water cannot dissolve in oil. Everyone knows that water and oil are chemically insoluble. They don't mix. Yes. So that thing only we check that the oil, the sugar, salt, and all other substances they get mixed with oil. Okay, sorry, water. But with oil, water and oil, they are insoluble and they do not get mixed with each other. Okay. So we did a test to check the density, okay, to check how a substance, like heavier substances, sink, okay. If the liquid has a higher density, then the substances, yes, it was disapproved. Okay. The substances that are, when the density of the water is higher than that of the substance, the matter, the matter will float on the surface of the water. Okay. Then we check the solubility and the insolubility of the materials. Okay, so this was today's experiment. Let me just see. Give me 1 minute.
Some researchers were even trying to call water a universal solution, but no, or solutant or something like that, because it dissolve, because everything dissolves in it. But then uh, they were teaching this in some class, and a student was saying, but that is false because oil does not dissolve in water, so they could not call it universal, whatever they were trying to call it up.
Mhm. Universal solvent. Yes. So that is right, Samir, because oil doesn't dissolve in water. Okay, Abraham, that thing only I was explaining that your oil, when you try to mix it, it will break into small droplets. But if you leave it, it will again all come together, stick together. It will not get dissolved in water, but it will float on the surface of water. Okay, it will
And my
float on the surface.
in the glass just now, all the oil came and stuck to the spoon. And when I lifted the spoon out of the water, the oil attached to the spoon, and there was little oil left inside the water.
Okay. Okay. Yes. So that thing happens. Okay. So that was all about today's experimentation on density, on increasing the density of the water. Okay. On soluble and insoluble liquids. All right.
Ma'am, I
Yes,
have a
Abraham.
prediction, ma'am. I will be able to take out water from the place, only pure water, if because the oil is not soluble in water.
Mm-hmm.
With a
Yes.
straw.
Yeah. Okay. So you can try doing it. Okay. You can try doing that. All right. You're going to use two tubes to separate it, the
Yeah,
water.
ma'am, I poured more oil in it.
Mm-hmm.
Ma'am, I'm actually using a
Why
pot
is
I
your
used to.
camera turning? I can't see anything.
It is because because this tablet.
It has the function to like
Center
turn
step.
wherever. Yeah. Yes.
Ma'am, can you see? So, ma'am, I'm using this fish pump because you're supposed to put a thing on the side if you forgot. Watch this. Watch this.
So okay, you can try this out later, Abraham. Okay. No
It's a
problem. Okay. Because try this out later. Where did you went?
Ma'am, this is the outcome of the experiment. Ma'am? Hello, ma'am.